All right, let's jump right in. As your chief systems engineer, my goal today is to lay out the complete blueprint for a brand new global micro EV. And let's be clear, this isn't just another car project. What we're talking about is engineering a vehicle from the ground up to be a truly viable, profitable solution for urban mobility all over the world.
So here's how we're going to tackle this. First, we'll define our core mission, the why behind it all. Then we'll get into our 4 non-negotiable strategic pillars. After that, we dive into the really tricky stuff, the global rulebook, what the competition is up to, and then the main event, our detailed engineering blueprint and how we get it to production in just 24 months.
You know, this is the fundamental question, isn't it? It's a massive engineering puzzle. We're not just designing a car. We're trying to create one single product that can navigate this incredibly complex, often contradictory maze of global regulations, insane cost pressures, and some really fierce competition.
Okay, so let's start with our guiding philosophy. And this isn't just some marketing tagline. This is the core principle that makes this entire project work, that makes it commercially viable from day one.
Now, let me be crystal clear. Frugal does not mean cheap. It's about being incredibly smart and efficient with our design choices. Think of it this way. Instead of designing a unique custom headlight assembly, we might specify a high-quality, off-the-shelf unit that already meets all our performance and regulatory needs at a fraction of the cost. That's frugal engineering. It's about delivering maximum value within a really tough cost structure. To pull this off, our whole development process has to be built on a rock-solid foundation. These are our 4 strategic pillars. They are absolutely non-negotiable.
And these aren't just vague goals, they're direct orders for the engineering team. 1. We design a single platform that meets the toughest rules from every major market. 2. We will live and die by a sub-450 kilogram weight limit. 3. We will be obsessed with manufacturing efficiency. And 4. We will make safety, especially battery safety, our absolute top priority.
So, with our own rules set, now we have to look at the external forces. And this is where the challenge gets really interesting, navigating the crazy, often conflicting, regulatory landscape of our key markets.
And right away, you can see the problem. In Europe, this vehicle class, the L7E, is basically a capable suburban car, meant for speeds up to 90 kilometers per hour. But in the US, a very similar vehicle is called a low-speed vehicle, an LSV, and it's speed limited to what's essentially a golf cart for neighborhoods. We're talking 2 totally different use cases that we have to solve with one core product.
So this number, under 450 kilograms, without the battery, this is everything. It's our hard red line. If we stay under this weight, we get classified as an L70 quadricycle in Europe, and we avoid the incredibly expensive and complex crash testing for a full passenger car. Every single gram counts.
And then you've got China. This one phrase from their upcoming battery safety standard is a complete game changer. No fire, no explosion. It means the battery pack can't catch fire, even if a cell inside fails catastrophically. You know, this one rule is so strict, it's going to dictate our battery choice for the entire world.
And just when you think you've got it figured out, Japan throws a curveball. Their unique vehicle class demands a width under 1,300 millimeters. That is way narrower than any of the competition. It basically forces you into a 1+1 tandem seating layout. You know, one person behind the other. So much for a single one-size-fits-all chassis, right?
Okay, so we're not doing this in a vacuum. To win, we have to know the playing field inside and out. So we've done a deep dive on our key rivals to really understand their strategies, what they do well, and where their weaknesses are.
And this table tells a fascinating story about the strategic trade-offs here. You've got the Wuling Mini EV, which is all about massive volume. They made a huge investment in traditional stamped steel tooling to get an unbeatable unit cost. Then there's a Citroën Ami, which is incredibly clever. They use a low-investment space frame and symmetrical parts, so they can be profitable at much lower volumes. And finally, you have the Microlino, which proves there's a market for a premium vehicle that can charge more by offering better safety and a more premium feel.
So, after looking at our own principles, the global rules, and what we've learned from the competition, we can now define the technical DNA of our vehicle. This is our engineering blueprint. Let's start with the heart of the car, the powertrain. A 48-volt system like the Amis, it's just not powerful enough to hit that 90 km/h L7E requirement in Europe. But a full 300-volt system from a bigger EV, that's way too expensive, too heavy, and just total overkill. Our analysis shows that 96 volts is the sweet spot. It gives us the performance we need while keeping the cost and weight right where they have to be.
When it comes to the battery, the choice is pretty much made for us.
To meet China's no fire, no explosion rule, lithium iron phosphate, or LFP, is really the only logical option. Its thermal stability is just way better than other chemistries. And hey, as a bonus, it also happens to be cheaper. So this one decision basically ensures our global safety compliance. It's a no-brainer.
And what about the body structure? Look, the massive upfront investment for a traditional monocoque body is just way too risky for a new project like ours. So we're going with a modern space frame architecture. It needs a much smaller capital investment and gives us the flexibility to use lightweight plastic outer panels. It's the smart, agile choice.
Every single number you see here is a carefully engineered compromise. We're keeping it around 3 meters long so you can actually cross-park it in crowded European cities. We're pushing the width right to the legal limit to give people as much shoulder room as possible. A high seating position gives you more leg room and a small footprint, and that short wheelbase gives us a tiny turning circle, perfect for city driving.
And here it is, the number that rules everything we do. Our target bill of materials cost is $6,500. And no surprise, the battery pack is the single biggest slice of that pie, taking up almost a third of the entire cost. Every single engineer on this team is going to have this chart burned into their memory. Well, a blueprint is useless without a plan to make it real. So here's our aggressive 24-month roadmap to take this thing from a drawing on a screen to a real car rolling off the line.
This is an incredibly compressed schedule. We have exactly 2 years from today until we start production. That means we have to run multiple things in parallel. Design, sourcing, validation, certification, all at the same time. It's going to be demanding for sure, but it's what we have to do to hit our market window.
So how do we build it? Not in some giant traditional car factory. We're going to use a micro-factory concept. This completely slashes our initial investment because we don't need those huge, expensive stamping presses and paint shops. Instead, we'll use pre-colored plastic panels and a much simpler, agile welding line for the space frame.
So, if you remember one thing from today, let it be this. Winning in this market is not about technology stacking. It's not about who has the biggest screen or the fastest 0 to 60 time. Success here is about the precise mastery of the good enough boundary. It's about executing the fundamentals, cost, weight, and regulatory compliance absolutely perfectly.
So, there you have it. The complete engineering and strategic blueprint. It's a plan built on frugal engineering, regulatory smarts, and ruthless efficiency. But the big question is still out there, isn't it? Is this just a clever solution for a niche market? Or is this the blueprint that could actually redefine the future of how we all get around in our cities? Well, that's what we're here to find out.